Materials have come a long way, from advanced energy harvesting materials, materials that can emit light, sound, self-healing materials, the list goes on. However, the materials that I'm interested in studying are a class of materials called magnetorological materials, or MR materials in short. These materials can react to an external magnetic field to change its consistency. Now, this might sound a bit primitive, since the simplest sort of material of this kind can be described just as microscopic ion filings dispersed in a fluid. But this is where it gets interesting. The ion particles can be dispersed in a bunch of other materials which give rise to more properties that we desire. Currently, MR materials are generally developed as a variable resistive material to shear forces, and are therefore used in dampers, microbrakes, and other similar dampening mechanisms. To prevent the ion particles from sedimentation, materials with thickeners are used, and thus a bunch of other different materials are born, such as MR greases, elastomers, plastomers, you name it. The advances of these materials are so rapid that researchers are trying their best to understand and subsequently engineer these materials to their desired applications. My thesis focuses on one specific type of MR material, which is MR grease. It is, as the name suggests, magnetic particles dispersed in grease. The thicker material allows for excellent anti-sedimentation while still retaining the properties of a fluid when sheared. However, due to its high viscosity and yield stress, it might not be the best at high performance applications. It has been brought to the forefront of research by scientists and engineers alike, essentially by modifying the material to have better qualities such as lower viscosity and higher magnetic responsiveness. The most common method of this sort of modification is just by using additives. It is of great importance to slow down and think. Will the additives do anything more than just modifying the grease itself? Recent studies have shown that some additives might actually cause the MR grease to degrade faster, even in idle conditions. This concern has prompted my study, which is working towards figuring out why this degradation occurs. Through microstructural and chemical analysis, I was able to identify the effects of some of these additives towards the thickener of the grease. And I'm currently working towards establishing a schematic mechanism that allows for a more illustrative approach towards understanding the grease degradation. It is hoped that the research allows for future development of suitable additives or even new additives to MR grease, which will potentially increase the possible uses of the material in advanced and intelligent systems